friends, welcome to the T.Y.B.Sc distribution theory class. In today's lecture, we will see the harmonic mean and mode of the beta distribution of second kind. So firstly, we will see the harmonic mean. Okay. So your harmonic mean. Okay. So here we have given that x is a beta distribution of second kind with parameter m and n. So density function of this is f of x is equal to 1 upon beta m and x raised to m minus 1 upon 1 plus x raised to m plus n, where x is lies between 0 to infinity and m and n are positive 0 otherwise. This is your PDF of beta distribution of second kind. Now we know that the formula of harmonic mean is reciprocal of expectation of reciprocal of random variable. Okay, so firstly we find the expected value of 1 upon x and then taking their reciprocal. So expected value of 1 upon x is nothing but, by definition of expectation, which is integration over x, since x is a continuous random variable, 1 upon x into f of x dx. Okay, so here x is 0 to infinity, 1 upon x, your density function 1 upon beta mn x raised to m minus 1 upon 1 plus x raised to m plus n dx. Okay, so 1 upon beta mn, which is constant and which is outside the integration sign, then we get the 1 upon beta mn into integration 0 to infinity, this 1 upon x, that nothing but you can write this 1 upon x as x raised to minus 1. Okay, so here x raised to m minus 1 and this minus 1 is this divided by 1 plus x. Here I have add and subtract minus 1 here. So m plus n minus 1 plus 1 dx. So 1 upon beta mn integration of 0 to infinity x raised to m minus 1 divided by this your 1 plus x raised to here m minus 1 plus n plus 1 into dx. Okay, now this integration is again you can use the beta function. So what we get from this is your 1 upon beta mn, and this is your, because we know that the integration of 0 to infinity x raised to m minus 1 upon 1 plus x raised to m plus n dx is nothing but your beta mn. So here m is m minus 1 and n is n plus 1. So this integration is by using beta function beta m minus 1 and n plus 1. Okay. So by simplifying this, what we get this using the gamma function. So this is gamma m minus 1 gamma n plus 1 divided by gamma m minus 1 plus n plus 1 into this 1 upon gamma m gamma n upon gamma m plus n. This is the denominator of denominator is numerator, so you can just write it, and here gamma m minus 1, you can write this gamma m minus 1, gamma n plus 1 is, you can write it n into gamma n. Okay, then denominator is gamma m plus gamma m plus gamma m plus n into this is your gamma okay. So this is gamma m plus n upon gamma m into gamma n. So this is get cancelled, this gamma n also get cancelled, and the remaining part is gamma m minus 1 divided by, this is your gamma m is nothing but m minus 1 into gamma m minus 1, here n is there, so your this get cancelled, so your finalized answer is n upon m minus 1. Okay, so this exists only m is greater than 1. Okay, or m is not equal to 1. So your expected value of 1 upon x is n upon m minus 1. So your harmonic mean is reciprocal of this 1 upon expected value of 1 upon x, so that nothing but 1 upon n upon m minus 1, so which is nothing but m minus 1 upon n, since denominator of denominator is numerator. So this is your harmonic mean of beta distribution of second kind. Okay. Now next is mode of the beta distribution of second kind. So finding the mode, we have to firstly write the PDF of distribution, then taking the derivative, first derivative, and equating it to 0, and we get the some value of x, and by using and putting this x in the second derivative of that particular function and check whether the second derivative is negative or not. If the second derivative is less than 0, then the function then the value of this your x is the mode of the distribution. Okay, so firstly here I have to uh, write the PDF of beta distribution of second kind. We have given the x follows beta distribution of second kind with parameter m and n. So density function of this is, every time I have write this because you remember that the density function of beta distribution of second kind. So 1 upon beta mn x raised to m minus 1 upon 1 plus x raised to m plus n, where x is lies between 0 to infinity and m and n are positive, okay, and 0 otherwise. So further I am taking the log of the density function, taking logarithm. So 1 upon beta mn is nothing but the, you have to just write the log of 1 upon beta mn x raised to m minus 1 1 plus x raised to m plus n. So we know that log of a into b is nothing but log a plus log b. So here I have just write log of 1 upon beta mn plus log of x raised to m minus 1 plus log of 1 upon 1 plus x raised to m plus n. Okay. So log of 1 upon a, that is a raised to minus 1. So by using the log, this is minus log of beta mn plus m minus 1 into log x minus m plus n into log of 1 plus x. Okay. Now differentiate with respect to x, then we get d dx by log of f of x is equal to, this is your constant term, so derivative of constant term is 0 plus m minus 1 into log of x is nothing but derivative of log x is 1 upon x minus m plus n, and the derivative of log of 1 plus x is 1 upon 1 plus x and derivative of x is 1. So this is the derivative and we equate it into the 0. So that means d dx of log of f of x, which is equating to 0. So we get m minus 1 into 1 upon x minus m plus n 1 upon 1 plus x equal to 0. Okay. So what we get? We get here that m minus 1 upon x equal to, this is negative part, so this goes to the right hand side, so it is positive, so that is m plus n upon 1 plus x. Okay. So I just, this is the numerator part in the left hand side, which goes in the right hand side, and which is denominator part. So by simplifying this, 1 plus x upon x equal to m plus n upon m minus 1. Okay. So that means 1 upon x plus 1 equal to m plus n upon m minus 1, or you can write it as one upon x is equal to m plus n upon m minus 1 minus 1. Okay. So that is equal to m plus n minus m minus 1 upon m minus 1. So what we get, 1 upon x is equal to, this is m plus n minus m plus 1 divided by m minus 1. So this get cancelled, so only the terms are remaining n plus 1 upon m minus 1. So this is the 1 upon x. So we have taking the reciprocal of it. So x is equal to m minus 1 upon n minus 1. This is the x value. Now if I have to put this value in the second derivative and the second derivative is negative for that particular x, then this x is a mod. Okay, so I have to taking the second derivative. So d square upon dx square log of f of x. Your log of f of x is this. This is your log of f of x. So the second derivative, that means derivative of this first derivative. So your first derivative is again, what is the first derivative? This term. This is your first derivative. So I have to differentiate this. That means which is equal to d dx by d dx into log of f of x. So here the first derivative is m minus 1 upon x minus m plus n upon 1 plus x. Okay, that means m minus 1 into derivative of 1 upon x minus m plus n into derivative of 1 upon 1 plus x. Okay, so this derivative of 1 upon x is minus 1 upon x square. This minus m plus n, and the derivative of this minus 1 upon 1 plus x bracket square. Okay, so that means these values are minus m minus 1 upon x square minus minus plus m plus n upon 1 plus x bracket square. Okay, this is your second derivative. So I just want to check this second derivative of log of fx at particular x. This is x is your m minus 1 upon n plus 1. That putting this x in this second derivative, and if this derivative is less than 0, then and then this x is your mod. So I have to just put the value of x here. So minus m minus 1 upon, this is your m minus 1 upon n plus 1 square plus m plus n upon 1 plus m minus 1 upon n plus 1 square. Okay, so this is your m minus 1 square. So one term is cancelled in the denominator and numerator. So I will just write this m minus 1 into n plus 1 bracket square, because denominator of denominator is numerator and this is your m minus 1 square. So this one term is cancelled, plus m plus n upon n plus 1 plus m minus 1 divided by n plus 1 bracket square. Okay, this bracket is extra, so I have to remove it. Okay, so again this, what we get, this minus n plus 1 bracket square upon m minus 1 plus m plus n into n plus 1 bracket square divided by m plus n bracket square. Okay, so this one term can get cancelled. So here in the both terms there is a n plus 1 bracket square is common, so I have outside in the bracket, and minus 1 upon m minus 1 plus 1 upon m plus n. Okay, so what we get, this n plus 1 bracket square into minus m minus n plus m minus 1 divided by m minus 1 into m plus n. Okay, so what we get, this n plus 1 bracket square upon m minus 1 m plus n. Okay, so in the remaining term is this get cancelled, so minus n plus 1. Okay, so what we get is, this is your minus n plus 1 bracket cube divided by m minus 1 into m plus n, and this is your less than 0. Okay, so what we get here, we get this second derivative is less than 0, so that means this x equal to m minus 1 upon n minus 1 is mode of the beta distribution of second kind. Okay, so this is the mode. So thank you so much.